Year 12 applications practice test. Write down the first 4 terms for each of these sequences. So we've got term 2. I'm going to let n be equal 1. So n be 1. So 1 plus 1 is 2. So I get term 2 here is equal to term 1 take 2. Okay, so term 1 is 11. So term 2 is going to equal 11 take 2, which is 11 take 2 is 9. So term 3 is going to be 9 take 2, because it's term 2 take 2, which is 7. Term 4 is going to be 7 take 2, which is 5. Okay, so the first 4 terms, I get 11, 9, 7, and 5. Next one. Here I get Tn equals 0.05 times 10 to the power of n. So I'm going to let n equal 1. So term 1 is going to be 0.05 times 10 to the 1. So term 1 is, when we times a number by 10, the decimal point is going to jump 1 spot to the right there, so it's 0.5. Term 2. Term 2 is going to be 0.05 times 10 squared, because here I've got n, and there's n, so letting n be 2 here, n equals 2. So I substitute 2 in for where I see this n. So term 2 equals 0.05 times 10 squared. 10 squared is 0.05 times by 100. Term 2 is going to be, when we times the number by 100, the decimal point jumps 2 spots to the right, so it's 5. Term 3 is going to be 0.05 times 10 to the 3. Term 3 is 0.05 times 10 to the power of 3 is 100. This is going to be 10 times 10 times 10. So that gives me 1,000 there. So term 3 is going to be 50, because my decimal point jumps 1, 2, 3 spots. So term 3 is 50, and term 4 is going to be 0.05 times 10 to the 4, which is 0.05 times by 10,000. Okay, which gives me 500 there. So my first 4 terms are 0.5, 5, 50, and 500. All right. C. Tn equals 3. Tn take 1 plus 4, with term 1 equaling 1. So I'm going to have T. I'm going to let n equal 2. N equal 2. Term 2 is going to be 3 by term 1, because here I've got n take 1. 2 take 1 is 1 plus 4. Term 2 equals 3 times term 1, which is 1 plus 4. That's 3 plus 4, which is 7. Term 3 is going to be 3 by term 2 plus 4. Term 3 is 3 times term 2, which is 3 times term 2, which is 7 plus 4. 7 3s are 21, plus 4 leaves me with 25. Term 4 is going to be 3 times term 3 plus 4. Term 4 is 3 times 25 plus 4. 3 times 25 is 75, plus another 4 leaves me with 79. So my first 4 terms are 1, 7, 25, and 79. Number 2, write an appropriate recursive formula for Tn plus 1 to represent each of these contexts. The number of books in a small library, beginning with 2,400 and decreasing by 350 worn-out books each year. There are no additions to the library because of budget cuts. So generally, we use T0 for an initial value which is going down. So T0 is 2,400 and Tn plus 1, the next term, is equal to Tn, the previous term, take 350. Okay, now we could have had T1 as 2,400 and Tn plus 1 equals Tn take 350. That's fine as well. Okay. We needed to use Tn plus 1 here. We needed the Tn plus 1, all right, because it asked for it. See, E, the value of a vehicle bought for 64,000 depreciating at 40% per annum. So the next term, Tn plus 1 equals Tn times R. And our T0 is 64,000. Okay? Now our ratio, if something decreases by 40%, that's 100% take 40%, which is 60%. So 60% is equal to 60 over 100, which is 0.6. So our R is 0.6. We've got Tn plus 1 equals 0.6 Tn. So R times Tn, with T0 being 64,000. Okay, again, you could have chosen to have T1 being 64,000. That was okay. But the better answer is this one, T0, 64,000. F. The size of a crocodile population, initially 250, increasing at 10% annually before 40 are taken each year to make shoes and handbags. So T0 is 520. Increasing at 10% annually. So when something goes up by 10%, you multiply it by 1.1. Okay, so our ratio is 1.1. So Tn plus 1 equals Rtn. So Tn plus 1, we figured out R, it's 1.1. 1.1 Tn. Now, we need to take away 40, because 40 are taken each year to make shoes and handbags. All right, so there's our answer there, with our initial term being 520, and you could have also written term 1 being 520, but again, because it's initial, T0's better. Number 3, write down the first 8 terms of the sequence defined by this. What, if anything, do you notice? So the first 8 terms. Okay, so we're going to have, I'm going to let n be 1 here, n equal 1 first off. So I'm going to have term 3, because 1 plus 2 gives 3. Term 3 is going to equal 1 plus 1. That's term 2. Take term 1. It's just n. So n's just 1 here. So term 3 equals term 2, take term 1. Term 3 is going to be term 2, which is 3, take term 1, which is 1, which gives me 2. All right. Term 4, same process. Term 4 is going to be term 3, take term 2. Term 4 is term 3, which we figured out, that's 2. Take term 2, which is 3. 2 take 3 is negative 1. Okay. Term 5 is going to be term 4, take term 3. Term 5 is negative 1, take 2. Negative 1 take 2 is negative 3. Term 6 is going to be term 5, take term 4. Term 6 is term 5, we just figured out that's negative 3. Take term 4, which is negative 1. If you take away a negative, it becomes positive. So this is -3 plus 1, which gives me -2. Term 7 is going to be term 6, take term 5. Term 7 is -2, take term 5, which is -3, which gives me -2 plus 3, which is 1. Term 8 is term 7, take term 6. Term 8 is 1, take -2, which gives me 3. So my first 8 terms, I should list them. So we've got term 1 is 1, and then we've got 3 as term 2, so 1, 3. So term 3 is 2. Then we've got term 4, -1. Term 5, -3. Term 6, -2. Term 7, 1. Term 8, 3. So what you see here is the numbers are repeating. Okay, so sequence. What do you notice? Sequence is repeating. Sequence is repeating. And as 1, 3, 2, -1, -3, -2. 1, 3, 2, -1, -3, -2. Okay. In each of these sequences, determine the lowest value of n so that Tn exceeds 600. So now, we're going to use our explicit rules here. Tn equals A plus n minus 1 D. This is the explicit rule for an AP. Why did I choose this rule? Because we've got plus 80 and plus 80. So our difference is 80. It's an AP, arithmetic progression. So Tn equals our first term A, which is 20, plus n minus 1 times 80. So now it asks us, determine the lowest value of n so that Tn exceeds 600. So I'm going to guess. Yeah, I'm going to put in 8. All right? And I'm going to get 20 plus 8 minus 1 times 80. T8 equals 20 plus 8 minus 1 is 7 times 80. T8 equals, let's have a look. You're allowed to use your calculator for this section. So we've got 20 plus 7 times 80, which is 580. Okay, so we know term 8 is 580. Term 9 is going to be 80 above that because the difference is 80. So 580 plus 80 is, that's going to be 660. Okay, so the lowest value of n so that Tn exceeds 600. Well, 600 is greater than, we're looking for Tn being greater than 600. So exceeds means greater than. So we've got n being 9. N equals 9. You have to write n equals 9 here because they asked to determine the lowest value of n. N equals 9. All right. Next one. We've got Tn equals 2 Tn minus 1 plus 10, with term 5 being 50. Okay, so the lowest value of n. So we've got, okay, let's figure out what this is saying. The next term equals 2 times the previous term plus 10. So term 6 is equal to 2 times by 50 plus 10. Term 6 is 100 plus 10. which gives me 110. Okay, now what you can do here is you can type this straight into the function on your calculator. All right, so I'm going to show you guys how to do that. But here I'll show you how to do it manually. All right, so if we look, we've got 50. So it's doubling. The next term is equal to double the previous term plus 10. So term 7 is going to be 2 times 110 plus 10, which is 220. 220 plus 10, which is 230. Term 8 is going to be 2 times 230 plus 10. So that's going to be 470. Term 9 is going to be 2 times 470 plus 10. So that's going to be 800 and something. We can type that straight into our calculator. So 2 times 470 plus 10 gives me 950. Okay, so again, the lowest value for n, so that Tn exceeds 600, it's 9. N equals 9 for this one as well. Okay, so next step. We've got 10, 20, 40, 80. So here we've got a common ratio. A ratio is equal to the next term over the previous term. Okay, so 20 over 10. 20 over 10 equals 2. And does that stay true for each one of these? Yes, because 40 over 80 is 2. 40 over 20 is 2. So the next term, the way we can write this one out, is Tn plus 1 equals 2 times Tn, with term 1 being 10. All right? Now, we want to figure out the number where Tn is greater than 600. Okay, what n is going to be. So we can now use the explicit rule. Tn equals AR to the n minus 1. All right? So A is our first term. A is 10. Okay? Our ratio is 2. So Tn is going to be 10 times by 2 to the n minus 1. So there's our, this is our recursive rule. And this is our explicit rule. Okay? So remember, you can't forget your first term, A. All right, now, what we need to do is figure out the value for n where Tn exceeds 600. So I'm going to have a guess. I'm going to put in T7. That's 10 times by 2 to the power of 7, take 1, which equals 10 times by 2 to the power of 6. So let's have a look what that is. That's going to be 10 times by 2 to the power of 6, which gives me 640. All right, let's look at T6. T6 is 10 times by 2 to the power of 6, take 1, which is 10 times by 2 to the power of 5. So 10 times by 2 to the power of 5, which is 320. So the first value of Tn, the first value of n, where Tn exceeds 600, is n equals 7. Should underline my answers. There we go. Okay, next one. Number 5, an athlete has a choice of 2 training schedules leading to the next Olympic Games. Start at 20 laps per day and increase by 3 laps on each subsequent day. Start at 20 laps per day and increase 5% of the previous day on each subsequent day. How far would she run on day 4 of each schedule? So let's look at this first one. Start at 20 laps per day. So our first term, T1 equals 20, and increase by 3 laps on each subsequent day. So our D is 3. And start at 20 laps per day and increase by 5% of the previous day on each subsequent day. So, yep. So let's figure this out. So our ratio here is going to be increased by 5%. That's multiplied by 1.05. Okay. So we've got here. How far would you run on day 4 of each schedule? So we've got Tn equals A plus n minus 1 D. This is for arithmetic progressions. All right, so T4 is going to be, it's going to be the first term, which is 20 plus 4 minus 1 times by D, which is our difference here of 3. T4 is going to be 20 plus 4 minus 1 is 3 times 3. 20 plus 3 times 3 3s are 9. 29 laps. Okay, GP, geometric progression. We've got Tn equals AR to the n minus 1. So T4 is going to be, A is our first term, which is 20. A common ratio, 5%. So it's going to be times by 1.05 to the n minus 1. So that's going to be 4, n's 4, minus 1, which gives me 20 times by 1.05 to the power of 3. T4 equals, we can do that one on our calculator, 20 times by 1.05 to the power of 3, which gives me 23.1525 laps. Okay. There's one answer there, 29 laps, and there's the other one there. How far would you run on day 20 of each schedule? So just the same again. T4, my mistake, T20. T20 is going to be 20 plus, that's the first term, plus 20, take 1, times 3. T20 for the AP. We're going to have 20 plus 19 times 3. I can type that straight into my calculator. 19 times 3, which is 77. And for the GP, we've got T20 is going to be 20 times 1.05 to the 20, take 1, which gives me 50.539 laps.